Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, let's just use the absolute convergence test. So it's saying the thing that you're trying to investigate. Well, look at the absolute version of the thing that you're trying to investigate, which will be this, and then if this thing here, if the absolute version converges, then the original thing will also converge. So the original thing here will also converge. So basically, you start out with this, look at the absolute version, that will be this. Determine if this thing here converge, then this will also converge. But let's see if this thing here will converge. So at the moment, n is discrete. So map a continuous function on top of this. Well, this here, this is our continuous function. So now integrate this. Integrating this. So visualize. So to integrate this, visualize this as this. You've got one bubble here, and then this is 1 over natural log. 1 over natural log of x. So visualize it as this. So for you to integrate this, it's really you looking for something that when you differentiate it, it will give you this. So notice that this is the exact derivative of the bubble here. So well, make this to be your initial guess. It's always going to be one notch higher than this, but you can't have natural log x to the power of 0. So make this to be your initial guess. Natural log of x. So now when you differentiate this, it will give you, well, 1 over, when you differentiate, make this to be your initial guess. When you differentiate it, it will be 1 over natural log of x, but then you've got to times the derivative of the bubble itself, which will be 1 over x. So you've got to, so basically that's this 1 over x here, and this here is this. So rather than using substitution, you can just integrate it straight away, or integrate it straight away. That will then give you this from 2 to infinity. Now put a very big number into here. So natural log of this, natural log of x looks like this. If you put a big number into here, this thing here will be very, very big, and then natural log of that very, very big number will be very, very big. So if you put a big number in here, natural log of the big number, and then so if you put a big number into here, natural log of that big number, and then natural log again, it will give you a big number. And then put 2 into here, that will then give you this. This is a constant. So now you've got a big number, take away a constant. Overall, it will be very, very big. So what that means is that this diverges. This integral diverges. So we can't really say anything about this. So we can't really say anything about this, because it's saying here that if you look at the absolute version of what you're trying to investigate, which is this, if it converges, then this thing here converges, but this thing here diverges. So we can't really deduce anything. We can only deduce if this thing here converge. If it converge, then this thing here will converge. Therefore, this thing here converge. But in our case, this thing here diverge. So we can't really deduce anything. So we've got to do something else. That something else would be us using the alternating series test, which I will continue in the next video.